everyone, I am Mrs. Padmashri from SNS College of Technology in the Department of Artificial Intelligence and Data Science. Today, I am going to explain the concept called Bayesian network in machine learning. So, let's explore what is this Bayesian network. As we had discussed so many networks like backpropagation network, neural network in machine learning, this is the another type of network called Bayesian network. So what is this Bayesian network? It's mainly used class of probabilistic graphical model, right? So this network has two parts. We can separate as a structure and parameters. So as we all know, a structure is called, a network will be having a complete structure, right? And parameters, there will be various parameters associated with the network. So the structure here, it is called as a directed acyclic graph, DAG. You must have studied in data structures and algorithm subject, DAG. So directed acyclic graph, a graph which has no directed cycles, and also a graph that has to start from the vertex and it ends in the another vertex. As we travel along the graph, the direction of the edges should not have any closed loop. Okay, so this this type of graph is called DAG. In short, we call it as DAG. So the structure, it expresses independencies and dependencies. So based on the variable associated with each node, and the parameter, as I said, it has two types, structure and parameter. The parameter has a conditional probability associated with each node. So how we define a Bayesian network? It is a graphical representation of different probabilistic relationship among the random variable which is present in a particular set. Say some set A or B. Right, A will be having some data present in it, B will be having some data present in it. So the network has a graphical representation based on the relationship among the variable A and B. So it comes under a classifier in machine learning if there is no dependency on attributes. It is conditional independent. So, due to this joint probability, we call it as like A is dependent on B. The probability of A which is dependent on the probability of B. Right? So because of this, the probability in Bayesian belief network is derived based on P of attribute slash parent. So the probability of an attribute true over the parent attribute. So this we can derive or we can study with one example. So here you can see a tree-like structure which has a root node, or we can say it's a parent node. So B and F, burglary and fire. Alarm. The center node is called the alarm node, and here P1 and P2 are the person which I have mentioned as calls. So two persons are there. Whenever the alarm rings, the person has to call another person or has to call some other unknown person to intimate whether if there is any burglary or fire. So this is one small example that explains about the probability, conditional probability present in the Bayesian network. This is a small tree-like structure we can say, or small Bayesian network we can say. So from this, how we are going to sort out the problem? We have, as I said, we have an alarm node A and we have the child nodes P1 and P2 persons, and we have the fire F and burglary B. With this, I am going to explain you one small problem, how we are going to calculate the probability. If there is any alarm, what is the probability of a person P1 if he calls to the another person, and what is the probability of the P2 whether he finds the burglary or fire if he calls or if he did not pick the call. So this is a chance of getting probabilities, right, that we are going to see here when we have alarm A node, right, which is installed in a particular house. that has two probabilities, whether that alarm will ring if there is any burglary or fire. These are the two parent nodes. As I already explained you, the alarm is the parent node which has two probability, whether P1 can call or P2 calls. Okay. So our P1 and P2 can call the some other person. There is a third chance. Some other person, say GFG or XYZ respectively. If there are few drawbacks. Sometimes P1 may forget to call a person, that is one chance, and P2 sometimes fails to call a particular person if he did not hear the alarm. These are some of the probabilities we took, and the question I am going to display here is find the probability. What is the probability that P1 is true, which means P1 has called some other person, and P2 is true, which means P2 has called some other person when the alarm is wrong but there is no burglary, and there is only one condition, F has occurred, which means no burglary but no theft, but there is a fire has occurred. So this condition, alarm has rung, what is the probability P1 called to some person and P2 is called to some other person, and when the alarm has rung because of fire. So this is the question you have to understand clearly. How this Bayesian network solves this probability kind of conditional probability questions. And here we have taken this probability of P1, P2, A, B and F. Here you can say this is negation of B, negation of F, anything. Okay. So when P1 and P2 are true events and these two are false events, we have taken these two are true and these three is false event. So the values which that I have mentioned here is maybe neither calculated nor computed. So randomly we have taken some of the values. Okay. So when B for burglary, P of probability of the burglary is true, we have taken some value, and burglary is false, we have taken another value. The same fire is probability of F is equal to fire is true, fire has occurred, and F is equal to false, fire has not occurred. So this is the conditions that we are going to take, and the values have written here. When what is the probability? What is the probability when both are true? When both burglary and fire happens, what is the probability of when the alarm rings? A is true and alarm not rings, A equal to false. So these values have written here. Okay. So the alarm node can be true or it can be false also. It may have rung or it may not. Okay. It has a two parent nodes, burglary B and F, which may be true or false. So based on this probability, we are going to the question that we got here. Person 1 is true, person 1 sometimes false. When the alarm rings, what is the value? When alarm is true, when the alarm is false, what is the value? So the person P1 node can be true or it may be false. Can be called a person, another person, or not called. So it has a parent node, the alarm A, may be true or false. So based on these conditions, same like person 2 also will be calculated. Either the person 2 may be P2 may be true, may be false. Alarm has rung or alarm is false. So these values have written separately based on the person 1 and person 2. So the solution here, we have to find it out. Both the persons are true and these two are false. So what is the probability of P1 when the alarm rang? Probability of P2 into probability of A, alarm has rung when there is no burglary and there is no fire. And what is the possibility? Probability of no negation of B, no burglary into probability of F, no fire. So we have to multiply all the units, all the values, and finally we will get one solution. Like what can be the probability if for this question when both the person either they must have called or they may not have called, either the burglary has occurred or not occurred. So this is the way that the condition probability works in the Bayesian network. So thank you so much.